Hey guys, so I've taken a couple of these coils and I put them in series. So same coils as some of my previous videos with these solid state. It's hooked up to this cap bank. There's the voltage, 73.25. That's the battery voltage, 26.27. That battery right there. Here's the current. This one's just kind of quickly threw everything together here to get it running. And here's the voltage of the spatter bank. Same one as the previous pulse motor videos. 57.55. So I'm going to take the power from the output here and put it to these batteries. There it's on. I'm going to take the power off and then reconnect it. We'll have the camera on the gauge here. There it's on. This one's not being used anymore. It's this one here. 57.55 still. 26.27. Hey guys, I've got these hooked up here now. The meters, this is the output to this bank here, 57.55. Just going to take the power from the battery, run it through the clamp meter here to the light bulb and show which direction it is as it's coming out of the battery. On the scope here, you can see right there on the bottom, the yellow. It's about, it says, let me just, hard to do this at one hand, but okay, I got it hooked up. Now I'll do this and measure. This should be about 100 milliamps. Yep. So 10 millivolts. This will be 100 milliamps. Both these are set on the same setting. 1 millivolt per 10 milliamps. So that's 100 milliamps pure DC coming out. Now we'll do the input, same thing, same demo. I'm not going to move the gauges around the meters, clamp meters. Hooking this to the output. Now I'm going to do the same with this light bulb. This one's actually hooked through the meter already too here, so I'll leave it the way it is. Just want to demonstrate the flow of electricity, like which way the current is going on the scope. So you can see when I turn the device on, which is the input and output. Oops, wrong one. Wrong end. What did I do here? Talking and doing stuff at the same time. So there you can see up there. This one's on the 5 millivolt setting up here. I'll measure that. Zero this out. There you go. You're looking at about 63 milliamps, and that's about what the gauge says too. Pure DC, so it's accurate. Both are accurate. Now I'll put this on the input. Haven't changed the orientation, so you know that the top up here, when this goes up, means battery power coming out of the battery. And it'll be the same with this one, because when I did the demo with the clamp here, it was power coming out of the battery, so it'll be opposite because it was coming down. Now anything that's above the line here will be power going in from the output. There, it's on. So this is power coming out of the battery. This down here is a like back spike that back feeds into the battery. And it happens at the same time here that power is going into the output battery. You can see the current here. These are 10 millivolt divisions too on the output. Top is 5. So here you're seeing way more on the output at the 57 volt range, and there's 27 volts on the input. And those coils are in series. I've hooked them up in series with just one circuit. So 57.54. Voltage dropped a bit because I ran a light bulb with the batteries. So you can see the gauge is 0. There's a tiny bit more power overall coming out of the battery. You can see above, like it's above the line more. So that's why the gauge is in the positive a bit. And here's the output. So just measure. So that's 69 milliamps coming out with these peaks up here. Go to the output now. And the highest part is right here. 88 millivolts, so 88 milliamp pulses. And that's the zero line. It's power coming out. I'll show you where the zero line is here. Just for reference, where it says 0. That's the 0 line. Let me just zero this out. any more accurate. Here, pause it there now. Here, that's the 0 line now. More accurate. What did I? 0 the meter out. You can see there now. The 0 line runs right through the center right there. Anything above is coming out. Anything below is going back into the battery. I'll 0 out the output too. Just meters drift a bit. Pause that again. That's 0'd. Find the 0. It's on the 0 right now. So anything below is kind of just rippling out of the battery, getting back through the diodes. And the top up there is and these are 10 millivolt divisions on the output. And these are 5 up here. Move that down. So input is the top and bottom is the output. I mean the negative coming out of the battery. Or actually no, I should actually change this up. It might help a bit. I'm not going through this extra diode. See what it does when I do that. That helps a little bit. Changes the input quite a bit too when I do that. Yeah, that helps quite a bit by putting it through the extra high-speed diode. And gauge is 0. And the voltage in the battery is going to keep climbing on the output. The input voltage should be 27 point some. 26.27, sorry. That's the output voltage. 57.55. And the output. It's hard to measure the current because there's some going both ways, but I'll just go to the input peaks here. So that's 82 milliamps. 0 the input out again here. Meter drifts a bit. 0'd. Pause it. Measure these peaks up here. These are 5 millivolt divisions, remember? So we're looking at 48 milliamp peaks. But overall power, here's a 0 line, so you can see overall there's more above the line than below. This is power returning back to the battery. Pulses, 84 milliamps pulse, the strongest ones. And I'll get some LEDs like I have here on the output and put them up there. I'll be back with that right away here. Okay guys, I've made one of my LEDs here. So the red one is on the bottom. The blue one is on the top. So the red one lights, power's coming out of the battery. Blue one lights is power going back into the battery. With the LEDs hooked up in series, it reduces the current flow through everything, so it doesn't flow as much current as what it does without the LEDs. And here's the voltage of the battery. So I don't have room to hook up the positive lead on the input here, but I'll show what the voltage is. 26.2827. So I'm going to hook it up. This meter likes to drift quite a bit. Zero it as much as I can here. Okay, now. There, it started. So there, you can see the blue one is just as bright as the top or the bottom one. Blue one's power going back into the battery. Pause this. So here's the top is power coming out, bottom is power going back in. You're looking at 28 milliamps on the power returning to the battery. Peaks. And about 17, 18 coming out of it. But the center line is right here. So there's a little more. That's pretty zero. The gauge here looks negative now. A bit negative. It's not moving anyway. And like I said, the top one is power going back into the battery. The red one is the power coming out. And take these off. Actually, let's sacrifice these LEDs to show a demo that they are what I say they are. Only one light with a DC load. So now I've just hooked the battery to the light bulb, but it's still through the gauge right here. So I'm just going to touch the LEDs. Should only see one light. There you go. I got this hooked up backwards. It looks like this one was the one that had the power coming out of the battery. So what I said is opposite. I just hooked it up in reverse. Yeah, this block is supposed to be facing out. My burnt brain put it backwards. So what you just seen is opposite to what I said, but only one light. That's because power is only flowing one direction. But when I hook it to this circuit, it flows both ways. There you go. The bottom one is power going back in. Top one's power coming out. And you can see it on the scope shots like I just showed you. But thanks for watching, guys. Just wanted to do the demo of putting these in series. There's lots of stuff you can do here. It's hard to show it all. That's why I do it and try to make it interesting too without just showing one thing all the time. But hopefully you guys enjoyed it. Thanks for watching. I appreciate it.